Sorry, folks. I don't know quite how this is going to go, because there's been morning talks where I felt better than I do today. And I'm also a little hoarse. Can everybody hear me okay? Yes. Everybody raise their hand if they can't hear me.
Camera. No.
Video camera.
The video.
Video, what does that mean? Should I,
It might
the
not
camera
hear you.
can't me. I'll try to talk about it. Also, this is like, I thought, oh, I'll just use really big slides because my laptop's really wide, and I just totally forgot I would be doing the talk on my laptop. I'd be doing it on this thing here.
Laser?
What? Can I just point at the screen without you yelling laser at me every time I use my arm, man? Do I need a laser to point at the screen? Look, there's the screen. Wait, what's he pointing at? What is he pointing at? What does he want us to look at? This thing here. This is a picture of pigs. Wait, I'm sorry, could you just use the laser to show us where the pigs are there? I don't Usually I'm really glad to get these morning slots because everyone's paying attention, but today I can't quite do it. I'm sorry. All right, well anyway, so here, the slides, when they get them up, which should be like as soon as the talk's over and I sit down and the next talk starts, but I don't know, it could be as late as tomorrow from here. If you want to look at them again, we should probably. All right, I'm wasting time here. Oh yeah, this talk is going to include at least 27 occurrences of the word suck. So if that kind of language is too strong for you, you should go down the hall now. Are those letters big enough? Can everyone in the back see them all right? Can I make the letters bigger? It's good. I really like the short rooms. The big conferences, they have these hotel rooms where the room is really, really narrow and long and deep, like a movie theater, and then everybody always sits like way in the back, and then they're like, "Can't hear you, man," and they're like half a mile away. All right, so I work for this company called IC Group, which is better known as Pobox.com because that's their domain, and they've been selling mail forwarding for at least 15 years and mailing list management for almost that long. And the CEO, Helen, we had this crappy billing system, billing and invoicing system, and the CEO had been trying to outsource our billing and our collections, and she talked to like everybody for a year and a half, and nobody was going to do what we wanted. They wanted to like do everything we wanted. Oh yeah, but we don't handle payments by check, only by credit cards. But you know, nobody pays by check anymore. Excuse me? It's one of our biggest clients, the University of Pennsylvania, which is something like the second largest private employer in Pennsylvania, pays by check. Anyway, so she told me and Rik to write one. Rik is the current Perl release manager. He knows a lot of stuff. He's really good to work with because he's not like sullen and grouchy like I am. He's always cheerful. I told him why yesterday. I'm sorry, I'm digressing. Well, if you notice that I'm digressing, like wave your arm at me and I'll try to get back on track because I probably prepared way too much material. Anyway, all right, so I've always wanted to write an accounting system. I know this makes me totally insane, but this is mostly because all the accounting systems I've ever seen sucked, and I was sure I could do one that wouldn't suck. So I was like, no, I could do that better. And so here's my chance to prove that I'm right. And thanks to Rik, I was right. I don't know if I could have done it without him, because he's better than I am, actually. Anyway, it did not suck. It's really, really good. And if you need a billing and accounting system, it's on GitHub, and I suggest that you take a look, and I'll be glad to help you with it. So I'm going to spend as little time as possible talking about the billing and accounting end of this billing and accounting system because you guys probably don't care that much about that. But I got to do a little bit. There's two basic use cases for IC Group, which are Pobox mailboxes where you pay $20 and we will forward, get a Pobox.com address, or it could be a private domain address, and we'll forward mail for you for a year. Mail to that address gets sent on somewhere else. Or you pay $35 a year, we will store it, you can read it online or by IMAP or whatever. And the list box, mailing lists, where you give us your list of people, and then you send a message and we distribute it to all those people and like keep track of who it didn't go to and charge you like 3 cents per message per person that it was delivered or that we attempted delivery to. So there's two quite different models, but those are the two basic services that we provided. And so we have this idea that like a customer has an account. account, and the life cycle of the account is they sign up and give us money, get the money in advance, almost always. For a few large customers who do bulk mailings and stuff, we were willing to extend them credit, but almost everybody has to pay in advance because, okay, never mind, I didn't explain that. Anyway, then we deliver some service for a while. If it's a P.O. box account, then we deliver service for a year. If it's a mailing list, we deliver service. We send out messages until you start to run out of money, and then we say, I'm sorry, we're not going to deliver any more mail. Can you give us more money? But anyway, when the money starts to run out, either because the time is running out or because you used it up, we send an invoice saying, hey, you want us to continue service, pay us more money. And then if they pay it, we go back to step 2 and we deliver some more service, and if not, then we terminate the service and we don't do it anymore. Any question? Well, perfectly clear, there's nothing trouble about this, right? But then there's like 10,000 and 19 special cases on top of that that make this an interesting project. People cancel early. We have a deal where if you buy 5 years of mail forwarding, you get the 60 free. And people will buy the $20 a year account, and then halfway through they'll say, I really want to be able to, I want you to receive my mail for me, so let's upgrade to the $35 service, or vice versa. And then what do you do? And the rule is you do not ever give the money back. That's the first law of acquisition. Once you have the money, never give it back. And Rik and I said that to each other many, many times over the course of this project. What's the business logic here? Well, we can't give the money back, so we have to do something else. We screwed up, and so we're going to give you a free credit. Refunds, I don't even know what that's doing up there. It doesn't exist. Courtesy accounts, there were way too many of those with the old billing system. Most of them have been eliminated. Meng Wang, who co-founded the company, used to give out courtesy accounts to like everybody he met. Myself, probably. And then, if somebody pays late, do you continue their service, and for how long, if you're actually expecting them to pay, and so on and so on. All right, so all kinds of crud here. The Moonpig data is organized as a big pile, unorganized pile of ledgers. Each ledger represents one account, one customer, who may be receiving multiple services, and often is receiving multiple services from us. And the ledger has in it like contact information, where we send the invoice. It has a history of all the invoices we've ever sent. It's a whole bunch of transaction histories, how much did they pay us, when, and how much we deducted from that for services rendered. All that stuff that I'm not going to mention again. And then attached to each ledger are one or more consumers, and each consumer represents some service that we promised to deliver in return for payment. And it has this consumer object has a method in it. It says, okay, here's how often you're going to charge, and how much you're going to charge. Here is how to send an invoice, and here's how to create a replacement for yourself when you start to run out of money, and stuff like that. The methods for asking it. Are you running out of money, and how long do you expect to live, and is it time to send the invoice, things like that. So ledgers and consumers. Everybody clear? This is like the one thing you need to know about how Moonpig works to follow the rest of the talk. The thing is called Moonpig, by the way, because after they wrote the first billing system, they said, man, we are never doing that again. Not until pigs fly. And then every time they had a meeting, well, we really need a different billing system because the one we have is crap. And then they started calling Moonpig, and so when we finally did actually write it, here it is, Moonpig. All right, moving along. There's no clock on this screen here. I left my phone over there. What time is it?
10 minutes in.
10 minutes in, thanks. That's good. Moving along, good speed. All right. Every day, we send a heartbeat event to every ledger. And then the ledger gets the heartbeat event and propagates it to all of its subcomponents, all of its invoices, all of its consumers, all of its everythings. Most of which just throw it away. They don't do anything because they don't have to do everything. They don't do anything in particular. But consumers notice that heartbeat event. And a consumer that gets a heartbeat event wakes up and says, gee, I wonder if I'm running out of money. And it tries to figure out if it's running out of money. If it is running out of money, it creates a replacement for itself that represents like next year's service or continuing service for a mailing list or something. And then the replacement upon creation typically will send out an invoice and say, hey, I'm here because you're running out of money and you're running out of service and you'd like to pay for some more. And then eventually the consumer runs out of money. It says, oh, I don't have enough to continue. And at that point, if it has this replacement, it hands over control to it. It says, okay, your turn. And then it dies. If it doesn't have one, then the last thing it does before it dies is terminate service. And this happens every day. There's a cron job that runs that sends a heartbeat. It loads each ledger, sends a heartbeat to the ledger. When the things settle down and all the invoices or whatever have been sent, replacements have been created, it goes on to the next thing. So, I didn't originally plan to structure this talk as a series of things that suck, but that's how it came out, because I'm a naturally sour and pessimistic person. Yes? Oh, you too?
Yeah.
You don't look sour. You look cheerful and jolly.
Yes, this is true.
Okay. Well, anyway, but that's how it came out. So much so that I actually took the part about things that are good and I moved it into the lightning talk that you'll hear tomorrow, because I didn't want to spoil the theme. So, one of the things that sucks is having to repair all your mangled data when some automated process messes up. And so, like, suppose the machine that's got the cron table that sends the heartbeats is down one day, and you don't send a heartbeat one day. Or, you know, the cron demon has died for some reason or something. Maybe the heartbeat job, for whatever reason, runs out of memory after it sent a heartbeat to the first 3,000 out of 10,000 ledgers and dies. And now you're sitting there thinking, geez, now I've got to figure out which ledgers and which consumers actually got the heartbeat and which ones didn't. I've got to re-heartbeat the ones that didn't get the heartbeat, and it's just a big mess. No, this is the law. Anything that handles heartbeat events is required to not assume that heartbeats arrive every day. You don't say, oh, I got the heartbeat, it must be a new day, I will charge you 5 1/4 cents, which is the price for one service. No. You instead, you keep track of when was the last time you issued a charge, you look at the current date and say, oh, it's a day since the last time I charged you, it's time to charge again. Or, oh, that's funny, I already charged you today, I guess I better not. Or, oh my gosh, I haven't charged you in a week, I better issue 7 charges. That's what you do. Everything has to properly handle missed heartbeats, extra heartbeats, duplicate heartbeats, any possible screw up in the heartbeating has to be handled, not in a heartbeating mechanism, but in everybody who gets heartbeats. Okay, well now, the cron machine is down, the cron demon is dead, the cron job doesn't get run, we missed a day, we didn't send out the heartbeats. Whatever, dude. Because what's going to happen? Well, you know, you send the heartbeats the next day, it's all just going to work. What's the fallout? Well, some customers might get an invoice a day late. Or, in the worst case is, some customers whose account should have been shut off, get shut off a day late, and they got a day of free service out of us. Clutch my pearls. Whatever, dude. Or suppose it crashes after it heartbeats 3,600 out of 10,000 of the ledgers. Well, you know, one thing you can do is say, whatever, dude, you know, they'll all get the heartbeat tomorrow and it'll get cleaned up then. Or if you want, just run the job manually. You know, and those 3,000 will get an extra heartbeat. That's okay, we'll deal with it. So, at my current job, I've tried to put this into practice too. They have these cron jobs where this would run, and then if it succeeded, that would run, and then that would run, and that would run, and then all this stuff would happen, and then if it's screwed up, you have to go back and fix it. And I tried to make it so that it would kind of self-heal, and then the next time it would run, it would just fix itself. And that seems to have been a pretty good success. Maybe the best thing I've done at this company so far. Yeah, so here's actually a piece of code. A consumer has a charges periodically roll. It just says, all right, just try to do the right thing if you get multiple heartbeats. It keeps track of when was the last time it issued a charge, or what was the date for which it issued that charge. And then when it gets called to charge, there's the heartbeat event. It finds out, okay, when's this heartbeat actually for? And then calculate when's the next time I should charge based on when I know I charged last time. And if that is in the future, until that's in the future, then we're going to issue charges over and over again and move it forward. So, if I haven't been charged in a week, then okay, this is going to be 6 days ago, and that's not ahead of now. So, all right, next date is the next date. Charge one day, and then set the last charge date to well, I just charged that, so set it to this, right? And then, if I couldn't charge, and as a result I expired because I didn't have any money, then send the event off to my replacement, if I have one, and quit the loop. Otherwise, go back and do it again. So we should charge this until the next time I'm supposed to charge is actually in the future, and then quit the loop, and that's all. But yeah, boy, it saved us a lot of trouble. Because, you know, these things always break. You always think, oh, well, the cron job will run, and then every day, blah, 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 and then, you know, one day it doesn't, or something goes wrong, pull your hair out. Costs a little, well, it's a significant amount of error to make this kind of thing reliable, but the cost gets paid back on this so fast because those system administrator guys who are supposed to make sure everything runs properly and the machines are up, you're not always very good. And if you're in a DevOps shop, then they're even worse.
Me.
And what? Oh, that was supposed to be self-deprecating. You know, I'm a dev. I got out of system administration because I hate it so much, and I do as little as possible. So it's probably my fault. All right. Here's another thing that sucks. Testing things that have to happen in real time, they like actually have like schedules to keep. If someone pays you for a year of service, and then 335 days from now, you need to send them an invoice saying, hey, your account's going to run out in a month. You want to buy another year of service. And how are you going to unit test something like that? You're not going to sit there or have a test do like sleep for 335 times 86, 400, and see if everything works, because then you're going to be sitting there a long time waiting for it to finish. And 335 days later, the test says, okay. I mean, well, okay, if you put it like that, the answer is obvious. You have to mock the clock. You have to make a pretend clock that somehow simulates the 335 days in the future. But, you know, people don't always do this, even when it's like tests that are like, have to wait a minute and a half. I've actually seen tests that would do like sleep 90, hoping that like something would happen in time. And they take 90 seconds to run because they're sitting around waiting for something to happen. Just, no. No. Tests have to run quickly. So the law is no object in Moonpig, no object ever, calls the system clock. If you want to know what the current time is, there's a special object called the environment. The Moonpig env object has a method on it called now that tells you what time it is. Normally, it just calls time, just like you'd expect. But if you're in the test environment, you've got a different Moonpig env object has been installed into the main Moonpig object. It's a different environment. And when you call now on it, it actually, well, it might actually call time. But it also has a method that says, oh, stop the clock. I want time to stop elapsing right now. And then you can say, oh, now I would like you to put the clock forward by 6 seconds, or 335 days. And it'll do that, and that's what now, every part of the program always calls now and finds out what time you said it was going to be. This fake time object also has a thing in it where if you try to move the clock backwards in time, it'll croak because you're not supposed to do that. Even the tests can't go backwards in time. If you're testing that, something's wrong. So you know, you see something like this. Oh, I would like 40 days to elapse. So the tests actually do this. All right, you know, we're going to start up some service. We're going to let it run, and it's going to run out of money. We've set it up so it'll run out of money in 30 days. Let's let 40 days go by and see if it's actually committed suicide. Great. It works, and you don't have to make fake test objects. They're the real test objects. You can see if they're expiring on the right day, sending the invoice at the right moment, because you can fake the clock. Questions? Let's see what else. This is a special case of things. It's like the world sucks, and this is why functional programming is so attractive. Is because it's trying to abstract away the world and do something with it, so that like you don't have to worry about what the world is doing behind your back while the program is running. So no Moonpig object interacts with the real world clock. No Moonpig object interacts with the database directly. It always goes through the environment. There's a storage object inside the environment, and it has the methods for talking to the database. And the tests can install a mock database and not worry about munching up the real data. And then throw away the mock database when they're done, and everything tests exactly the same. No Moonpig object ever posts email. It never calls send email itself. Instead, it gets the email sender out of the environment. And that way you can be sure that when you run your test, and it's generated 115,000 test invoices that you're going to examine and make sure they're correct, that you don't actually accidentally send 115,000 test invoices to some real customer. You can't, because they're all using the email sender object. And in In the test environment, the email sender object is a fake one that has methods on it where you can like say, okay, what mail was actually sent? Let me look at that. But it never actually sends any mail. You can't break. At least it's really hard to break. You really have to go out of your way to screw this up. We never used any file system storage, but if we had, we would have had a Moonpig and file system. And don't ever open a file. You ask the file system object to do it for you. It's a little extra trouble on the front end, and a lot less trouble on the back. This Moonpig end thing, it makes it really easy to get it right. And it's really hard to mess up. Like, wait a minute, no, of course I'm not going to open a file. I'm going to go through the environment. And there's no way to talk to the database except going through the environment. You have to work really hard to get hold of the database handle. But the Pig environment has it right there for you, and it's the right one, and it just is going to work. I hate floating point. I hate it so flames on the side of my face. I hate it so much. Is it right for anything? I don't know. I've never seen the application for which floating point is correct. Those actually, you guys are really smart. There must be something they had in mind for it. I don't know what it is. 35 years of computer programming, I've never found a use for it. Years I have been saying, I have been looking at accounting systems where you would pay, for years I've been getting bills in the mail for $0.00. And what happened there? What happened there? Some jackass actually stored the amount that I owed them as $123, 45.0000002. It printed out as $123.45. I paid it off. Now their accounting system says that I owe them $0.000023, and they duly send out an invoice for 0.00, and you can't pay it off. You have to get on the phone, and they're like, oh, okay. I've said probably every month of my life for years, or every good accounting system, we're not going to use any goddamn floating point numbers. So all amounts of Moonpig denominated in millicents, 1,000th of a cent. In a $20 pull-outs account, it has to charge you $20 over a period of 365, possibly 366 days. But let's forget about weekdays because they suck. They suck there. That's 5,479 millicents each day. That's how much you get charged. And then, because you don't want all these non-digit numbers in your program, you have these two tiny little utility routines, cents and dollars. We write cents, 95, that's 95 cents. Oh, actually, it turns into 95,000. Simple enough. You can check. Tests can, thank you. 17. Tests can check whether all amounts are exact and are computed to be exactly what they ought to be. You don't have to put anything in the test that says, oh, we'll make sure that the amount is within half a cent of what it ought to be. No, the amounts are exact. And it happened many times that we would run the test and it would be off by 2 millicents. See, that's funny. What's going on there? But it has to be exact. And when we investigated it, it turned out there was some incredibly horrible bug that was causing this 2 millisecond discrepancy, and it would have been a complete catastrophe if it had made it into production. It was really funny that the bugs that resulted in like $10,000 discrepancies were always really simple and easy to find and not that big a deal. And the bugs that caused a 2 millisecond discrepancy were always really subtle and, yes,
Yeah,
well,
and if it had been floating points and it was a 2 millicent thing, you would have assumed that it was the floating point.
I might have assumed it was a floating point round-off error and shrugged my shoulders. Yes, but integers you can't round off because you either have like 1 or 2. Yes, thank you, Paul. Right, moving along. Rounding errors suck. All right, so this is not going to eliminate rounding questions because you cannot divide a $20 fee by 365 days, although actually I've been thinking the last couple of days we actually should have used rationals. So 365 times the amount we charge, $54.79, adds up to $19.99.835. What happens to the extra 165 millicents? Well, you have to decide. You can't just kind of shrug your shoulders. Well, you could shrug your shoulders, but something has to happen to it. But it makes it really clear that there's something that has to be decided here that's doing this decision. And Rik says, well, nobody cares. things. That's because Rik is more practical than I am, maybe. But I'm a mathematician, something has to happen to it. I wrote the logic there, the answer is the customer keeps the extra 1/6. Okay. And there's places in the code where it says, okay, if the amount is less than 500 millicents or less than 1,000 millicents or whatever, don't bother sending an invoice. And explicitly, it doesn't screw up. All right, dates and times suck, and I can tell you that. You always recognize a programmer because you ask them if they have a strong opinion about time zones. Programmer will... Anybody else yell over that? All time in Moonpig is accounted internally in universal time because it doesn't have time zones, and it doesn't have daylight time, and it doesn't have, unfortunately, it has leap seconds because some knucklehead decided to use UTC instead of TAI. Anyway, it's simple, it's easy, everything is UTC. Trying to deal with multiple times inside the same program is idiotic. No, you convert them all to one standard on input, and then you convert them back on output, just like you do with anything else that has multiple representations. Yes. All right. So everything gets turned into UTC on the inside. Good. We used the date time module off of CPAN, and it's okay. We like it all right. It works all right. The internals of it are fine. The API is pretty terrible. It has the wrong methods. This method's the default method, and that like advertised method is almost never the one you want to use. The answer is always, oh no, you shouldn't have used that reasonable seeming method. That's like foo. You should have used sometimes foo backwards, upwards, and that's the one you wanted to use there. That's always the one you want. It's the one with the really long, obscure sounding name. And there's way too many mutators because times are like numbers. They represent number. Times are numbers, and they should not be mutable. Numbers are not mutable. No, this is like date time has all these convenient mutators. Rik has this awesome story about this time that he accidentally mutated a date time, but it was stored in multiple places, and like every object in the system went berserk because it thought it had a date time for like a certain time, but he accidentally mutated it to a different time, and it changed everywhere. And like you don't expect your numbers to do that. All right, so fine. That's it. Anyway, I'm sorry. Date time is okay. Date time duration is a shit pile. And it sucks, it's useless. And this program, right? All right, here I'm going to give you date time. Boy, I wish I'd said yes to that. All right, this is date time for April 2nd, 1969, midnight. I make another date time for the current time. I subtract them. That minus there is overloaded. I subtract two date time objects, which is okay. I get a date time duration object, which is where things start to go wrong. You get an elapsed, that's what it gives you, date-time duration object, and then you say, okay, well, I'd like to know how much time this actually represents. Date elapsed in units, seconds. Totally straightforward. Let us find out, what does this program actually do when I run it? Is this big enough for everyone to see? Let's make it bigger because I hate it so much. There's their program, okay? The same one. Are we good?
Yeah.
Oops. Does anybody know what this means? I had to look this up. It means I shit in the milk. So we wrote a Moonpig, I wrote a Moonpig date time module. It inherits for date time, but it overloads the things that are screwed up. It changes the overloading plus and minus. So if you've got a Moonpig date time and you add a number to it, it's interpreted as a number of seconds. So we've got n is some time, like April 2nd, 1969. This is 4 seconds later. And this is 15 minutes earlier. And if you want to do some more complicated thing, let's say plus days 7, which is totally easy to read, and it does exactly what it appears to, and days is a one-liner. It's just generating the right number of seconds. There's no problem there. And if you subtract 2 of these Moonpig date times, you don't get a Moonpig date time duration, you get a number of seconds. And that way you can like see, oh, is this number greater than or less than days 7? You could actually do arithmetic on this thing. What a concept. And like compare it with things instead of getting told that you have to like drink shitty milk. All right, well, I was actually really afraid when I started building this. Do you really think this is a good idea? You know, there's going to be some place where like we're using it, we think we're going to be getting back one of these numbers, or it's going to like break like 5% of the time and cause us more headaches than it was worth. And I was happily, I was wrong. It was flawless and it worked perfectly, and I loved it. And I strongly recommend this approach. And the Moonpig source code's all on GitHub. And even if you don't want to use Moonpig, which is enormous, you can grab Moonpig date time. It's only like 100 lines, and just copy the code somewhere. Check it out. So it was an effective approach. All right. Relational databases suck. They suck. I hate them. We use them because they're efficient. Not because they're convenient, not because they match the problems, not because they're easy to think about. They're great if your data is relational. If you've got a huge amount of relational data, like, God, I don't know. Library, I don't know, maybe not. I'll bet it's not. Anyway, if you've got a lot of relational data, it's good. Our system does not have a lot of relational data. It has these ledger objects, which have consumer objects. Relational databases are really good if your data is relational. Object hierarchies are not at all relational. They're not even a little bit relational. They have these like there's directed graphs of objects that like have pointers to other objects that might be shared. They're not relational. And then, so somebody decided you should use this thing called an object relational mapper that tries to store your object hierarchy, your directed graph, of a relational database. And it's so sad because they try so hard for so little effect. Okay. Well, your object, you don't have an object anymore. Well, it's an object, but it only represents a row from a database. And you push on it and try to get an object that represents something a little better. No, it's just so, it makes me so sad because they work, they struggle so much and achieve so little result. Objects just aren't like relational databases. And then every time your object model changes, which is supposed to happen all the time, that's the whole point, right? Oh, it's object, they're really flexible, you can like add a new member, you can delegate to some other object, all this awesome stuff with all these objects, except that now, every time you change your object model, the relational database has to change, and you've got to do an alter table and regenerate all the missing data, or like move all this stuff into some other table, and then you're like, I don't want to change the object model, we'd have to redo all those tables. And then it's kind of like the tail is wagging the dog. I thought this was going to be a good idea. Okay, I mean, maybe it was worth a shot, but like, it seemed like a reasonable thing at the beginning, but I think, I don't know, I don't think the jury's out on this anymore. I think it's a crappy idea. I don't know what the right idea is, unfortunately. I wish I did. I'm going to show you what's not the right idea. Moonpig storage use case is you need to set a heartbeat to a ledger. Load a ledger, send it a heartbeat, it's going to do some stuff, and then we're going to throw it away into the next ledger. The solution is we have a SQLite table. There's 2 columns. The primary key is the ledger's globally unique identifier. So we can look up a ledger by its GUID. And then the data is a copy of the ledger that's been frozen with Perl's storable module into a string. And so we look up the ledger, get the string, we use the storable STAW method to throw it into a ledger object, and we've got the object. It's perfect. It's got all of these pointers pointing around to consumers and stuff. We send it the heartbeat, and then when we're done, we store it back. This is an incredibly terrible idea. It worked really, really well for us. I can imagine 1,000 projects that this would be an incredibly terrible idea for. For ours, it was the right idea. Rik and I agree. If we had tried to do this with an ORM, it would have taken at least 6 months longer. It took us about 1.5 years as it was. If we tried to do it without the ORM and store the stuff in a relational database, we would not have finished, ever. We would have failed. There's some complications to this one. Once you resuscitate an object out of the database, that's no good if you don't actually have the classes that this object thinks it's a member of. You have to have the code for those classes compiled, but you might not. You get the object, oh my gosh, what class is that? Well, one law is data gets stored, not the implementation. Don't store the code. We thought for a minute, what if you store the code along with the object? Terrible idea, because then if you've got a bug in your implementation, then it's stored with 150,000 objects, and then like you fix the bug, you still got 150,000 buggy objects. No. You store the data, not the implementation. When the object is resuscitated, it gets the right implementation. That means you have to be a little careful when you're changing the implementation, that you change it in an upward compatible way. In practice, this was not a problem at all. Each object gets stored along with a list of all of the roles that need to be composed together to build its class. Rik wrote this module called class compositors that then puts them together into a class and then put the object into that class. It worked fine. This problem here is not actually a problem with our approach. It happens with ORMs also. You retrieve the same object twice from the database. You have to actually get the same instance of the object in your program. You have two instances that represent the same stored object, then the first thing's going to store back its changes, and the second thing's going to store back its changes and overwrite the first thing's changes. So you got to make sure that that doesn't happen or have some way of dealing with it. And most typically, you do it by adjusting the API. This is do with ledger methods. I want to deal with this ledger with this GUID, and then inside you've got a function that gets the ledger as an argument. This guy can make sure he can keep track of which ledgers are active in the system and have not yet been stored back. And if anybody else later asks for the ledger with the same GUID, while this thing is still running, it'll just give it back the same object. It took me a surprisingly long time to get this right. It's the part of the system I think I should have done better at. How much time have I still got? Nobody cares.
It's 10:52.
When am I supposed to stop?
You got 13 minutes.
Oh, good, 13 minutes, that's good, that's good. What if the ledger contains another ledger? Well, it doesn't actually happen in our system, so there wasn't any problem. Okay, but what if it did? Well, that would screw up Perl's garbage collection anyway. A list of things that suck would not be complete without mentioning Perl's awesome garbage collection. It would have been state of the art. It had been invented in 1967. But it was invented in 1987, and now we're stuck with it in 2007. Oh my God, it's 2013. No wonder I'm so fat. Okay, but, I mean, suppose you actually have this problem. Well, that's okay. Every ledger has at least one unique identifier. It has this GUID. It also has an account number for the users, the account's account ID. You don't store a ledger inside another one. If you had to, you would store a reference to it by its ID, and then look up the ID using this nice end storage module. And then similarly, if you need to talk about a consumer outside of its ledger, you store its GUID. Everything has a GUID. After I learned Moose on this job, after a couple of years of using Moose, Rik asked me, hey, what do you think of Moose? What's your opinion? Well, I don't know. It's all right. Automates some stuff, but introduces a lot of complexity, and then the error messages are really shitty, and I don't know. Seems like kind of a wash. Oh, wait, no, except for roles. Roles. Moose, that makes it all worthwhile. I would totally use Moose every time because of roles. Roles are awesome. And, I was about to have like a 5-minute digression here to talk about why roles are awesome, but it's, I don't have that much time, and it's thematically appropriate, so I'll tell you tomorrow. Roles. So, things that are good. And actually, the talk is going to take a turn for the better now, because the rest of the talk is about things I like. It's not that bad. We wrote this module, a system called Stick. It gives us a web API. It's really, really easy. We've got some method there called, say, current balance. I don't even remember what this is a method on, but if you want to make this method available by the web API, then you stick a couple of declarations at the top, and then you stick the word publish in front of the method name, and now suddenly this is available on the web API. And it's got a bunch of options. If it turns out it's a method that you should be using post for instead of get, you say, oh, that's a post method. And if you don't want it to be made available at its regular name, which is the default, terminate as of, say, then you say, oh, I wanted a path terminate, not terminate as of. And if it gets arguments, then you just list those. So it gets a termination date, which should be a Moonpig datetime object. When you post the object, it should be JSONified. And then this guy here gets called, and the arg has a hash with all of these things that don't have hyphens, like termination. And after I finished writing this talk, I thought, I really shouldn't even talk about stick. Because you're probably not going to use Moonpig. Although, if you're interested, I would glad to talk to you about it. It's really good. There's a good chance you could use stick. So maybe next year. But it's on GitHub, and it makes turning your thing and giving your program a web API makes it really clean and easy. Any object that does this role, stick role routable, could participate in the way URLs get mapped to objects and actions. To participate in this role, you have to have a subroute method. Subroute's simple. It gets an array of path components, which were split out of the URL. And you should look at the first couple, decide if they make sense, and if so, remove them from the array, and then pass back an object to handle the rest of the path if there's any left. So for example, if you're a ledger, you've got a bunch of consumers, you might get handed a path that says something like, oh, I would like the termination date from consumer blah, blah, blah. And you'll look at, oh, you know what, this is on the next slide. There we go. So you've got some path that represents a ledger already, path to ledger, the URL for a ledger object, and then the ledger could say, okay, well, since this thing routes to me, I will say if the next component is consumer, and then there's some ID number, I'll make that a URL that routes to the consumer object. And so I will say, okay, well, let's say I get a route, and the route, if the first component is consumer, then I'll throw the consumer away, get the next component, which is the ID, find the right consumer, and return it. And if not, I'll return this, which generates a 404. And then the consumer has a subroute in it, probably one written automatically. It says, oh yeah, and if the first component of the path is get termination date, then just return your termination date. Easy enough. This thing here, actually, you don't have to write it yourself because there's this role called hasCollection, which I'm about to describe, and we'll write it for you. Ledgers have, among many, many other roles, and hasCollection role is they have a collection of consumers. And the collection should also do these roles. And that means that the ledger automatically gets a consumer collection method. And a consumer collection object, it's just a collection object. You can say, give me all, and it'll give you back all the consumers. You can say, count, it'll tell you how many. You can say, find a consumer with this GUID, and it'll give you back that one consumer. And you can, and we did, use this frequently throughout the code. But then it also, the consumer object is a stick routable. The collection already built into it has a subrouter for its count method, its all method, and the thing that looks up by GUIDs. So the ledger, if the ledger can route the consumer's path to its consumer's collection, then it gets these things automatically. They just work. And then by composing this mutable role, that tells the collection that it should also allow add, a post method called add for adding a new consumer. And then if you want to add some special purpose thing, we composed in this, this extra role that adds a router for this path. So you give it a template object and a bunch of things to fill into the template, and it'll make the consumer that way. And then if you use this to route to a consumer object, the consumer itself is a stick routable that knows that if it sees this path, it should call adjust replacement chain, and if it sees this path, it should call quote for extended service, and if it sees this path, it should kill itself. And then there's a bunch of other stuff. There's a collection pageable, which adds methods for getting pages, and there's a sortable and a filterable, and I forget what else I wrote, most of which we didn't use, but we felt we might. This routing thing, the web API is called Stick because they had tried 3 or 4 different systems for doing this at IC Group, and none of them had stuck. But this one is going to stick. And I think it has. My wife suggested that. Let's see. What else is good? Object, well, this is the last slide, and I've got 5 minutes left, so I'm going to finish early. That's awesome. Unit tests often have a lot of repeated and duplicated code, and what's good for getting rid of repeated and duplicated code? Object-oriented design. And Rik wrote this nice module called test routine that makes each test file into an object-oriented class with Moose. And each test that's run gets passed a self-object that represents the testing state. So it makes this test object, passes it to the first test, and then the test runs, and it can store stuff in the test object, set up its test data in the test object, and then another test can use that, so you don't have to do it over and over again. You have methods on this test object that you can call from the various tests and say, okay, now test this, and now do that, or tear this down, or whatever. Tests can load upon other tests easily just by instantiating the objects. And so you get everything that Moose gives you for your tests. Short summary. If you're writing tests, this is the thing that's probably most useful in this talk, is you should check out test routine. It's on CPAN. All the tests are written in like the test more style, just like they're used to. In fact, it is test more. It's not just is test more, you have to load test more. It's just a framework that you embed your tests into, so you can use test more, test most, or whatever it is you like to use. If you need to build a web API, this stick thing is really good for that, and actually has some documentation. And serialization and unserialization, and objects get passed over the wire as JSON. Each object gets a little method to tell it, oh, and here's how you serialize this part of yourself. And the routing is really good. It's really easy to handle. If you actually need a billing and accounting system, talk to me, Rik. Moonpig is free for use. And, fortunately, under-documented, but really powerful. You will like it. That's the summary. If software sucks, elicit it. You can use that. Thank you very much. Does anybody have any questions? Nobody has? Yes, sir.
So if you wanted to extend this for a system that was different, basically you just need to rewrite your own consumers?
Yeah, that's exactly right. You need to write your own consumers, and there's a good chance that the consumers that you need will not be different very much from the ones that we already have, because we've had to write several. But yeah, that's right. You do that, and the PO box consumers that compose these guys have a bunch of business logic and things in them for PO box specific stuff, and that's not on GitHub.
Right.
But yes, exactly so. Yes, sir.
What is the size of a ledger when stored, and when you bring it into the database and put it in core, how long does it typically stay there before it's saved out again?
How long does a ledger stay in core before it's saved out? I do not know.
Is it short-lived or long-lived?
It's fairly short-lived, because typically the model is that we post an event to the web API, and the event is going to get sent to a ledger, possibly 2 ledgers. The ledger gets brought in, the event gets processed, it doesn't stay, and then it gets stored or thrown away. So I would imagine fairly short. We did briefly have a problem that the maximum column width, the maximum field width in SQLite is not too long, and there was some guy, some ledger that had like hundreds and hundreds of consumers, and it got too big. And Rik and I looked at each other, and we were like, and I said, we could just gzip the data before we store. That's what we did. Yes?
So practically speaking, did you run into any cases where you needed to make an attribute required after you had stored it, and you ended up with object serialization you couldn't do essentially?
Yeah, so we end up with, say, an attribute that needed to be required, but after it was stored on a bunch of objects that didn't have it. And what we would do in a case like that is normally there is, typically there's going to be some reasonable default, right? And then you don't say, oh, the attribute is required. You say it defaults to this, and you fix it up so that when it gets loaded from the database, it says, oh, I don't have this. I will lazily initialize that guy, and then it gets stored back and it has it. But yeah, we foresaw the possibility that we might have to make some backwards incompatible change to the object model, leaving ourselves with a bunch of invalid objects in the database. And what we planned to do in that case was write some job that loads up each ledger in turn, upgrades the objects properly, and stores them all back. We thought we would probably have a series of those. Okay, well, here's how you upgrade from storage format A to storage format B, from B to C, then it didn't actually come up. But yeah, we did foresee that this was going to happen. And I don't think it would be that hard to deal with if it did come up. I can only say that I don't know because it never did. All right, I've got 30 seconds left.
Hey, if you find the object-oriented databases on your way to just denormalize and access the right database?
Do we try any object-oriented databases? No. We considered them, and we decided to go with this thing instead. All right, thank you very much, folks. I will be glad to answer questions.